Hello, Algebra 1 students. Let's take a look at Chapter 3, Section 1, Graphing Linear Functions. What makes a relation or an equation a function? We reviewed that at the beginning of the year. It's when every x has one and only one, or exactly one y. That's when a relation is a function, or an equation turns into a function. Every x has one and only one y. It passes the vertical line test, or when you check the set of the function and each x is paired with one y. So that's when it's a function. But let's talk about being linear functions. When it's a linear equation, its graph is going to be a line. That's pretty simple. Linear equation, its graph is a line. A linear equation is written in standard form when it looks like this: ax plus by equals c. Now this is just our vocabulary, and as we work through some example problems, this will all make a little bit more sense. But in standard form, the c here stands for the constant. We've reviewed this in class. X is a variable, y is a variable. It means they will vary, but c here is a constant. It is not going to change. It does not have a variable. Alright, linear equations, by the way, notice that the x is not squared, nor does it have a negative exponent. X and y have an exponent of an understood 1. That's one way to know it's a linear equation before you graph it. After you graph it, it should be obvious because it should be a line. Alright, the x-intercept is the x-coordinate where the graph catches or crosses the x-axis. In football, an interception is when you catch the ball. So I like to say an x-intercept is where you catch or cross the x-axis. Vice versa, the y-intercept is the y-coordinate where the graph catches or crosses the y-axis. So again, x-intercept where it crosses the x-axis, y-intercept is where it crosses the y-axis. Alright, the key concept chart here is taken from your book, talking about standard form. Standard form is a form that you will be expected to know from this day forward. If I ask you to write an equation in standard form, it needs to look like this. Understand these are some very important aspects of standard form. The a, the number in front of x, cannot be negative. It has to be greater than or equal to 0. It cannot be negative. And a and b are not both 0. And a, b, and c are integers. Now there's that word. They expect you to know what an integer is. Integers means it's not a fraction. Integers are those numbers on a number line, whole numbers, and they're negatives, not fractions. What can't be a fraction? A cannot be a fraction. I guess I don't need it to be plural. It cannot be a fraction. And it cannot be, what else did I say? Not a fraction and not negative. So not negative or a fraction. That's very important to know that about A. Alright, it has a greatest common factor of 1. So here are some examples. 3x plus 2y equals 5. Notice 3 is an integer, and that's A is greater than 0. And x equals negative 7. X equals negative 7, is that in standard form? Yes, it's understood that B must have been 0, and our C is negative 7, and C can be negative. It's A that cannot be negative. So you'll have to manipulate the equations sometimes to be able to obey all of these rules. But it is very important for you to understand the rules for standard form. Alright, so let's look at some equations. It says here to determine whether each equation is a linear equation. And if it's linear, write the equation in standard form. Identify A, B, and C. Well, the first problem I see is there's a typo here. This should just say equals 2. And I'm going to go ahead and spill the beans that all 4 of these are linear. Because if you look at my x's and my y's, they do not have exponents greater than 1 or less than 1. So they're all going to be linear equations. So now the new task is to determine, so we can just go ahead and say yes, linear. So we're going to put it in standard form. Well, when I take away the z that's not supposed to be there, it's already in standard form. So A here is 5, B is 3, and C, our constant, is 2 for number 1. Alright, now number 2, there's a fraction in front of x, and that's okay, it's still linear. What I have to do is I have to rearrange this problem so that it looks like standard form. Now let's review. AX plus BY equals C. This is standard form. So I don't have a problem with where x is. I need to bring y over to join x. So now I have 3/4 x minus y, because that's going to cancel, equals 8. Now remember that box up above, it says that the coefficient of x, which is a, cannot be less than 0. Or excuse me, it cannot be, oh, it has to be an integer. That's the rule that I'm breaking here. It's not an integer. So remember, you've got the power to change this to an integer. So if I'm going to multiply the a by 4, I have to multiply everything in this whole equation by 4. And that's going to give me the result 3x minus 4y equals 32. So now we can say A is 3. B here is a negative 4, because remember that's the same thing as saying plus negative. B is a negative 4, and our constant C is 32. Alright, number 3, I need to rearrange. Let's get a new color. The 4x is on the wrong side, so if I subtract 4x to rearrange, I'm going to have negative 4x plus y equals a negative 5. Now here's where it's an integer, it's a negative 4, but it says in our rule for standard form that it can't be less than 0, and negative 4 is less than 0. So the easiest solution here is to just multiply everything times a negative 1. If I multiply negative 4x times negative 1, and negative y times negative 1, and negative 5, multiply it times negative 1, our new equation is going to be a positive 4x plus a negative 1y equals negative times negative makes positive 5. So our A is 4, our B is an understood negative 1, and C is 5. Alright, I'm going to leave number 4 for you to rearrange. Remember, you'll need to take care of your negative, because you can't have A less than 0. Alright, moving on to your next page. Let's use graphs and tables. Find your x and y intercepts. There's that word, intercepts. That's where does it catch the x-axis and where does it catch the y-axis. Well, this is your y-axis. This is your x-axis. And it looks to me like this is the point where it hits the y-axis. So x, it travels 0 on x. So the y-intercept is going to be 0, and then it went up to 250, 0, 250. And the x-intercept, which I might should have said first, you're going to the right 10. So x is 10 and you went 0 on the y-axis. Notice the x-intercept has an x value and the y is 0. The y-intercept has a y value and the x is 0. Okay, our next problem says let's analyze this table. A box of peanuts is being poured into bags at a rate of 4 ounces per second. The table shows the function relating to the weight of the peanuts in the box and the time in seconds the peanuts have been pouring out of the box. When I look at this chart, I see a 0 here and I see a 0 here. So this tells me when x is 0, before time begins, there's 2,000 ounces of peanuts. Then they're pouring and pouring and pouring, and the next time I see a 0, it's talking about the weight, and 500 seconds have passed. So that's when they're finished. They've poured out all of the peanuts. Now, the first part says determine the x and the y-intercept. Well, where there's a 0 is where there's going to be an intercept. But be careful. The x-intercept, remember, is when there's an x value and the y value is 0. So where do I have an x value and a y value of 0? It's at the end. So the x-intercept came last for this problem. And the y-intercept is where x is 0 and the y value here is 2,000. Alright, I'm going to leave this table for you to analyze. We're going to move on to graphing these equations. We're going to first learn to graph using the x-intercept and the y-intercept. Now remember, to get the x-intercept, the y value needs to be 0, and to get the y-intercept, the x value needs to be 0. So when I plug in 0 for y, so to get the x-intercept, I am replacing y here with 0. I'm going to solve for x. Alright, to isolate x, I need to add 4 to both sides of the equation, and that would give me 4x equals 4. Now I need to divide both sides by 4, and x equals 1. So I have now found the y-intercept is 1, 0, and I can come over to my graph and plot 1, 0. Notice how it's sitting nicely on the x-axis. Alright, to find the y-intercept, remember this is your x and this is your y, so I'm going to plug in 0 for x. So it'll be 4 times 0 minus 4 equals y. So to solve for y, since 4 times 0 is 0, negative 4 equals y. And so my y-intercept is at 0, negative 4. So 0 on x and go down 1, 2, 3, 4 to a negative 4. 0, negative 4 is my y-intercept. So this is my y-axis, y-intercept. You only have to have 2 points to determine a line, so I have 2 points now. I can graph my line. I'm going to save B for you to practice on your own. Try finding the x and y intercept. And our last method for this section for graphing a linear equation is to make a table. And you've seen these function tables before where we put our function rule here in the middle. Whoops, that's supposed to be 2x plus 2. So 2x plus 2 goes in the middle. And we're going to pick some numbers to plug in. You only have to have 2 points, but I'm going to go ahead and do 3. So 2 times 0 is 0, plus 2 is 2. So 0, 2. Hey, I just found my y-intercept on accident. And 2 times 1 is 2, plus 2 is 4. So here's another nice point. 1, 4. And 2 times negative 1. It's always nice to check for negatives. That's going to give me negative 2 plus 2 is 0. Hey, I just found on accident my x-intercept. So you don't necessarily always find your x and y intercepts, but here's 3 points, 0, 2, 1, 1, 2, 3, 4, and negative 1, 0. So there's 3 points there on my line. So that's how you make a table, and I would like for you to try